Dark Fireworks, presented by Science at NASA. Warning: the movies you are about to see might make you feel uncomfortably close to the Sun. On June 7, 2011, Earth-orbiting satellites detected a flash of X-rays coming from the western edge of the solar disk. Registering only M for medium on the Richter scale of solar flares, the blast at first appeared to be a run-of-the-mill eruption. That is, until researchers looked at the movies. "We've never seen anything like it," says Young, a solar physicist at Goddard Space Flight Center. Half of the Sun appeared to be blowing itself to bits. Video beamed to Earth by NASA's Solar Dynamics Observatory revealed one of the most dramatic explosions ever. In terms of raw power, this really was just a medium-sized eruption, says Young, but it had a uniquely dramatic appearance caused by all the inky dark material falling back to the stellar surface. Solar physicist Angelos Forlidas of the Naval Research Lab calls it a case of dark fireworks. The blast was triggered by an unstable magnetic filament near the Sun's surface, he explains. That filament was loaded down with cool plasma, which exploded in a spray of dark blobs and streamers. The plasma blobs were as big as planets, many larger than Earth. They rose and fell ballistically, moving under the influence of the Sun's gravity like balls tossed in the air, exploding like bombs when they hit the stellar surface. Some blobs, however, were more like guided missiles. In the movies, we can see material grabbed by magnetic fields and funneled towards sunspot groups hundreds of thousands of kilometers away, notes Forlidas. SDO also detected a shadowy shockwave issuing from the blast site. The solar tsunami propagated more than halfway across the Sun, visibly shaking filaments and loops of magnetism en route. As remarkable as the June 7th eruption seems to be, Young believes it might not be so unusual. In fact, he says, it could be downright common. Before the sharp-eyed Solar Dynamics Observatory was launched in 2010, space-based telescopes observed the Sun with relatively slow cadences and/or limited fields of view. They could have easily missed the majesty of such an explosion, catching only a single off-center snapshot at the beginning or end of the blast to hint at what actually happened. Could more dark fireworks be in the offing? Says Young, I wouldn't be a bit surprised. For more close encounters with the Sun, please visit science.nasa.gov.